Native iOS development has historically demanded a high toll, learning Swift, wrestling with storyboards, and committing entirely to Apple's isolated ecosystem. But today, you can bypass that learning curve. You can build native mobile applications using the web frameworks you already know. In the next 6 minutes, we are going to write a complete Fahrenheit to Celsius converter using standard web code, wrap it in a native container, and deploy it directly to a physical iPhone. Most modern software experiences now run on the phones people carry everywhere, rather than just in back-office browsers. Showing that you can deliver a functional mobile app using your existing web skills demonstrates that you can handle end-to-end project requirements. To compile iOS applications, there is one non-negotiable rule: you need a Mac. Apple's hardware constraints require macOS to run the necessary build tools. This is the required toolchain you need to get started. You need Node.js for your JavaScript runtime, Xcode to supply the iOS simulator, Visual Studio Code for authoring, and the Ionic CLI to generate the workspace. By stacking these specific open-source tools against Apple's proprietary software, we create a secure bridge. This exact setup is what allows standard web code to eventually compile into a native application. Step 1 is generating the initial project. Open your terminal, initialize a blank Ionic project using the Angular template, and launch your local development server. Inside your code editor, locate the main HTML template and delete the default code. We are going to replace it with an Ionic range slider component to capture our user's Fahrenheit input. Next, we add the math. In your TypeScript file, write a simple function that listens to the slider's value, subtracts 32, multiplies by 5/9, and outputs Celsius. This is the home module file. It contains the most common failure point in this process. For two-way data binding to work between your slider and your TypeScript logic, you must explicitly import the forms module here. If you skip this, the app will fail silently. Save your files and check your local browser. You should see a working slider that calculates the temperature instantly as you drag it back and forth. You now have a working, mobile-grade interface, and you built the entire structure with web technologies without writing a single line of Apple's native code. To get that web app onto a phone, we use a translation layer called Capacitor. It takes your standard HTML and JavaScript and completely envelops it inside an outer native iOS shell. Go to your terminal to initialize Capacitor and add the iOS platform. This generates a distinct iOS folder containing a complete Xcode project. Moving updates into that native project is a two-step execution. First, run a web build to compile your code. Then, run a sync command to push those compiled assets across the bridge into the Capacitor shell. This separation of environments is intentional. You iterate quickly in the web browser and then sync the final product over to guarantee native performance on the actual device hardware. Now, we transition out of the web environment entirely. Open that newly generated iOS workspace file directly inside Apple's Xcode. This is the main Xcode toolbar. Click the Target dropdown, select a simulated hardware profile like the iPhone 15 Pro, and hit the Run button to execute the application build. The iOS simulator will launch automatically. Your temperature converter will boot, but it now features a native iOS status bar and responds to mobile touch interactions. Seeing the app run cleanly in the simulator validates the workflow. Capacitor successfully translated your web logic so that Apple's native hardware tools can understand it. To test on a physical iPhone, we have to clear Apple's security roadblocks. Inside Xcode's Signing and Capabilities tab, check the box to automatically manage signing and assign your Apple ID from the Team dropdown. Plug in your iPhone, select it from the device menu, and press Run. On the first physical launch, iOS will actively block the app with an untrusted developer warning on your screen. To clear this block, open Settings. Navigate to General, scroll to VPN and Device Management, tap your developer certificate, and explicitly trust the application. Tap your app icon again, and the converter will open. Bypassing these security checks and operating your code on a physical screen proves you now command the entire end-to-end mobile deployment pipeline. Look at the sequence we just completed. You tested an app in a web browser, simulated it virtually, and deployed it to an iPhone. All 3 instances ran perfectly off the exact same foundational codebase. Each piece of the stack handles a specific task. Angular dictates the logical structure, Ionic renders the mobile user experience, and Capacitor executes the native hardware integration. In upcoming labs, we will scale this architecture. we will pull complex applications from Git repositories and build continuous integration and continuous delivery pipelines to automate deployment. But right now, you have a tangible mobile application running on your personal device. You have upgraded your portfolio from theoretical web knowledge to proven